Right, grade 10s, I'm back with the next video on the answers, and these questions would be exercise 3, number 11 and 12 you had to do on page 33 to 34. Question 11 at the bottom here says two wave crests, both with a positive amplitude, move towards each other and meet at a specific point. What type of interference occurs? And that would be constructive interference. Where the resultant disturbance will have an amplitude that is the vector sum, or the sum of the individual amplitudes, and it will be a bigger disturbance because both have a positive amplitude. Right, question 11.2 says explain this type of interference with the aid of appropriate diagrams. So we can do it in 3 steps. If we have a pulse A moving to the right and a pulse B moving to the left, so they move towards each other, and they get to a point where they are superpositioned. If pulse A's amplitude would be a little a and pulse B's amplitude will be a little b, the two pulses, when they are superimposed, will have an amplitude of little a plus little b. So this is a plus b. The pulse width, if I can say that the symbol of pulse width is W, if both pulses have a width of W, the superimposed pulse width would also be a W. So this is a diagram we can use to show constructive interference, where the resultant disturbance during the superpositioning has a much bigger amplitude. It's actually the vector sum of the individual pulses' amplitudes. Right, I'm not sure whether they asked for this, but after the interference, pulse B will continue moving to the left with an unchanged pulse width and amplitude, and pulse A would be moving to the right with an unchanged amplitude. Right, question 12. Two pulses P and Q in a rope approach each other with the same speed. Pulse P has an amplitude of 4 centimeters. Pulse Q has an amplitude of -6 centimeters. That indicates that the one disturbance is above the rest position and the other disturbance is below the rest position. Both pulses have a length of 8 centimeters. The crest of pulse P and trough of pulse Q meet. Assume that no energy is lost. Give the definition of a pulse. The pulse is a single disturbance. That is propagated through the medium. What phenomenon occurs when the two pulses meet? To be specific, destructive interference. Draw a sketch with labels to show what happens when pulse P and Q meet. So pulse P and Q will meet, and the resulting disturbance will have a negative amplitude of 2 centimeters. And the pulse width will be 8 centimeters, and this would be P plus Q, which is 4 minus 6, which gives us minus 2 centimeters. Question 12.4. Draw a sketch with labels to show what happens to pulse P after the interference. So pulse P will move undisturbed to the right with a pulse width of 8 centimeters and a pulse height amplitude of 4 centimeters. Pulse P, question 12.5, moves a distance of 0.6 meters in 1.5 seconds. Calculate the speed of pulse P. So speed would be distance divided by time. So it's 0.6 divided by 1.5, and that gives us 0.6 divided by 1.5 is 0.4 meters per second. Oops, I'm off the screen again. 0.4 meters per second. That brings us to the end of this homework marking, and I'll talk to you again in the next video. Thank you.